We often think of our solar system as a completed map, a cosmic neighborhood where every resident has already been accounted for. But what if the most massive member of our rocky family is actually hiding in plain sight, just beyond the reach of our eyes? High above the bright plane of the planets, a gravitational ghost might be tugging at the strings of everything we think we know. This is the mystery of Planet 9, a hypothetical giant that challenges our understanding of home and our place in the vast dark. For centuries, we believed the edge of our world ended at Saturn, then Uranus, and finally at the frozen winds of distant Neptune. Yet, even with our most powerful telescopes, the outer reaches of our solar system remain a blurry frontier filled with unanswered questions. Astronomers have noticed that the smallest, loneliest rocks at the edge of space are behaving in ways that simply do not make sense. These icy wanderers are not moving randomly. They are being herded like a flock of sheep by an invisible, incredibly massive shepherd. This suggests that something huge, perhaps 10 times the mass of Earth, is lurking in the shadows thousands of times further than we are. To find this phantom world, we must become cosmic detectives, looking not for a planet itself, but for the footprints it leaves behind. Our story begins with a realization that the vacuum of space is never truly empty, but governed by the silent, iron laws of gravity. Every object in our system, from the sun to the smallest pebble, is locked in a complex dance of pulling and pushing against one another. When we see a dance move that doesn't fit the music, we have to assume there is a partner we simply cannot see yet. In 2014, researchers Scott Shepard and Chad Trujillo first noticed a strange pattern among the most distant objects in the Kuiper Belt. They found that these objects all shared a similar orbital alignment, as if something had physically pushed them into a specific, narrow corner. 2 years later, Caltech astronomers Konstantin Batygin and Mike Brown provided the mathematical backbone for what we now call the Planet 9 hypothesis. Their simulations showed that a massive planet on a highly tilted, elongated orbit could perfectly explain the bizarre behavior of these icy rocks. But the scale of this hunt is almost impossible to imagine, covering a patch of sky so vast it could hide 1,000 giants. If Planet 9 exists, it is an introvert of the highest order, sitting in a cold exile where the sun is just a bright star. The search for this world is not just about finding a rock, it is about uncovering the secret history of our solar system's birth. To understand why this ghost world is so difficult to catch, we have to grasp the sheer, mind-breaking scale of the outer solar system. Space is not just empty. It is vast in a way that our primate brains, evolved for the African savanna, struggle to process. If the Earth were the size of a nickel, Neptune would be a baseball sitting 2 city blocks away from the Sun. But Planet 9 would be located in another neighborhood entirely, nearly 20 city blocks further into the cold, dark outskirts of town. At this distance, the Sun is no longer a warm, life-giving orb, but a tiny, distant spark that provides almost zero heat or light. Finding it is like looking for a single black marble in a dark warehouse the size of the Pacific Ocean with a dim flashlight. This isn't just a physical challenge, it is a mathematical puzzle that requires us to reconsider everything we know about planetary orbits. The trans-Neptunian objects we track follow elongated oval paths that should, statistically speaking, be pointing in every possible direction over time. Yet, like a choir singing in perfect harmony without a conductor, these distant rocks all tilt and align toward one lonely side of space. Konstantin Batygin and Mike Brown found that the chance of this happening by accident is about 0.007% or practically impossible. Their calculations suggest that only a massive gravitational anchor could keep these orbits from drifting apart into the chaotic mess of the void. This anchor would act as a counterweight, its gravity pulling on the small rocks to keep them huddled together in a stable formation. But the math is a double-edged sword. While it tells us that a planet should be there, it doesn't tell us exactly where. Searching for it requires us to map the entire sky in tiny, high-resolution patches, a process that takes years of expensive telescope time. We have already searched the bright parts of the sky, leaving only the most difficult, crowded regions near the Milky Way's dense center. If Planet 9 is sitting right in front of the core of our galaxy, it would be lost among the billions of brighter stars. Some critics argue that we are suffering from selection bias, only seeing the objects that happen to be in the areas we look. They suggest that the alignment we see isn't a secret planet at all, but a byproduct of our own limited and patchy observations. To prove them wrong, we need to find more distant objects, expanding our dataset to see if the pattern holds true everywhere. Every new discovery in the Kuiper Belt is a new data point in a high-stakes cosmic trial where Planet 9 is the defendant. If Planet 9 is truly out there, we must confront the awkward question of how such a giant ended up in the cosmic wilderness. Our solar system was not always the orderly dance of spheres we see today. It began as a violent, crowded nursery of infant planets. Billions of years ago, the gas giants Jupiter and Saturn were much closer together, engaging in a gravitational tug-of-war that reshaped everything. In this chaotic era, a fifth giant planet, a sibling to Neptune and Uranus, might have been caught in the crossfire of these titans. As Jupiter migrated, its massive gravity could have acted like a cosmic sling, hurling its smaller sibling out toward the freezing dark. This ejected planet theory suggests Planet 9 is a refugee, a world cast out from its family and forced into eternal exile. But there is a more mysterious possibility. What if Planet 9 isn't a native of our Sun at all, but a stolen prize? In the Sun's birth cluster, stars were born close together, and it is possible our Sun kidnapped a planet from a passing neighbor. This would make Planet 9 an exoplanet, hiding right under our noses, a visitor from a different solar system altogether. Whether a refugee or a captive, the existence of this world challenges our fundamental understanding of how planetary systems form. To verify these theories, scientists use supercomputers to run thousands of digital simulations, recreating the birth of our solar system. In these digital universes, when they add a ninth planet with specific mass and orbit, the strange behavior of the Kuiper Belt suddenly makes sense. Without the ninth planet, the simulations often result in a solar system that looks nothing like the one we actually live in today. Yet, computer models are just math on a screen. We need physical proof, and some researchers believe the proof is in the Sun's tilt. The Sun itself is tilted by 6 degrees relative to the orbits of the main planets, a mystery that has puzzled astronomers for decades. A planet as massive as Planet 9, pulling from its distant and tilted orbit, would have enough leverage to slowly tip the entire solar system. It is like a small child on the far end of a seesaw, somehow managing to balance a group of heavy adults on the other side. Every piece of indirect evidence from the tilted Sun to the clustered rocks points toward the same massive, invisible conclusion in the dark. But science demands a direct observation, a photograph of the ghost, which is where the hunt becomes a race against technology. As new observatories like the Vera C. Rubin telescope come online, the hiding places for Planet 9 are rapidly shrinking to nothing. Searching for Planet 9 is a task that pushes the absolute limits of our current astronomical technology and our human patience. If this world is as far away as we suspect, it would be remarkably faint, hiding in a region of space we have barely mapped. Most of our surveys look for things that shine or reflect light, but at such distances, sunlight is a rare and precious resource. To see a planet 20 times further than Neptune, we are looking for an object that is 100,000 times fainter than Pluto. It is like trying to spot a single firefly hovering in front of a massive stadium floodlight from several miles away. But astronomers have a secret weapon: infrared light, the signature of heat that every massive object radiates into the cold. Even a frozen giant at the edge of the solar system is warmer than the absolute zero of the vacuum behind it. By digging through old data from satellites like WISE, researchers are looking for tiny dots that moved between frames over several years. If an object shifts position against the stationary background of distant stars, we may have finally found our cosmic wanderer. Another revolutionary method involves looking at the cosmic microwave background, the ancient afterglow of the Big Bang itself. As this ancient light travels toward us, a massive planet could act as a gravitational lens, subtly distorting the radiation we detect. It is as if we are looking for a tiny ripple in a vast, sunlit pond to prove a stone has been thrown. However, the sky is a very big place, and even with these methods, we are searching a haystack the size of a galaxy. This is why the Vera C. Rubin Observatory in Chile is so crucial. It will scan the entire visible sky every few nights. It will create a high-definition motion picture of the universe, capturing everything that moves, blinks, or drifts in the deep dark. Within the next few years, this telescope will either find Planet 9 or prove once and for all that it was a mathematical illusion. But even if we don't find a planet, the search itself is revealing thousands of other strange worlds in the outer reaches. We are discovering that the space beyond Neptune is not empty, but a bustling frontier of icy debris and mysterious dwarf planets. Every failed search is not a defeat, but a refinement of our map, showing us exactly where the giant is not hiding. The mystery of Planet 9 is forcing us to become better explorers, sharpening our tools and our vision for the deep dark. But what if the ghost we are chasing isn't a planet at all, but something far more exotic and ancient? Some physicists have proposed a mind-bending alternative. Planet 9 could be a primordial black hole the size of a grapefruit. Born in the high-pressure furnace of the Big Bang, these tiny black holes would have the mass of a giant planet. They would be completely invisible to traditional telescopes as they emit no light and reflect nothing from the sun. If this theory is true, we wouldn't be looking for a sphere of rock and ice, but a point of infinite density. Such an object would still exert the same gravitational pull, herding the Kuiper Belt objects into their strange, aligned orbits. Detecting a grapefruit-sized black hole in the outer solar system would be the ultimate challenge in the history of science. We would need to look for tiny flashes of light caused by dark matter particles annihilating each other near its edge. Or perhaps we could send a fleet of tiny, laser-powered probes to look for gravitational anomalies as they fly past. While the black hole theory sounds like science fiction, it highlights how desperate we are to explain the missing mass. Whether it is a planet or a black hole, the evidence suggests that our solar system is not as finished as we thought. We are living through a second age of discovery, where the frontiers are not oceans, but the cold reaches of space. This search reminds us of our own smallness, a tiny civilization clinging to a warm rock near a middle-aged star. It humbles us to realize that a giant could be living in our own backyard for eons without us ever noticing. Our ancestors looked at the stars and saw gods and monsters. We look at them and see math and mystery. Yet the feeling remains the same, a sense of wonder at the things that move in the shadows of the unknown. Every time we point a telescope into the dark, we are asking the universe to tell us its deepest secrets. Sometimes the universe answers with a clear discovery, but often it simply gives us a more interesting question to ask. The search for Planet 9 is a testament to the human spirit, the need to know what lies over the next hill. As we peer into the abyss, we aren't just looking for a planet, we are looking for the truth of our origin. If Planet 9 is not a planet and not a black hole, could it be a collective illusion of our own orbital neighborhood? Some researchers suggest the clustering we see is simply a massive, invisible disk of icy debris orbiting the Sun. In this scenario, millions of tiny rocks work together, their combined gravity acting like one single, massive entity. It is the difference between being pulled by one giant and being caught in a swirling current of countless pebbles. This theory would mean our solar system has a hidden second belt, much further and more massive than the Kuiper Belt. However, even this explanation requires a huge amount of mass that we haven't actually seen with our telescopes yet. Whether it's a disk, a planet, or a hole in space-time, the math screams that the outer edges are heavy. This search has reignited a debate about what it actually means to be a planet in the modern astronomical era. After the demotion of Pluto in 2006, the criteria became strict. A planet must clear its own orbital path of debris. If Planet 9 is found, it would be the first true major planet discovered in over 170 years. Its discovery would push the boundary of the known world out by a factor of 10, changing every textbook on Earth. We would have to ask, how many other giants are lurking even further out in the mysterious Oort cloud? The Oort cloud is a spherical shell of billions of icy objects that stretches halfway to the nearest neighboring star. If the Sun could capture Planet 9, it could be hiding an entire family of rogue worlds in that icy shell. Space is not a flat map. It is a three-dimensional ocean, and we have only been wading in the shallowest tide pools. Every time we think we have reached the end of the world, we find a new horizon waiting to be crossed. The hunt for Planet 9 is a bridge between our past as stargazers and our future as a spacefaring species. It reminds us that science is not a finished book of facts, but a living, breathing process of constant revision. We are currently in the waiting room of discovery, the tense moment before the lights come on and reveal the truth. Until that day, Planet 9 remains a beautiful ghost, a mathematical whisper calling us deeper into the dark. If Planet 9 is finally caught by our lenses, the first thing we will want to know is, what does this world actually look like? At such a staggering distance from the Sun, the environment would be a masterclass in extreme planetary physics and chemistry. It is likely a super-Earth or a mini Neptune, a type of planet that is common across the galaxy but missing from our own system. Without the intense heat of a nearby star, its atmosphere would be a frozen cocktail of hydrogen, helium, and perhaps methane ice. Deep beneath the outer layers, the pressure would be so immense that water might exist in a strange, hot, solid state called supionic ice. This planet would be a dark cobalt blue or a deep violet, absorbing what little light reaches it from the distant pinprick sun. It would be a world of perpetual twilight, where a midday sky looks darker than the deepest midnight on a moonless Earth. But could such a cold, lonely place host something even more shocking, like internal heat generated by its own massive core? Tidal forces or radioactive decay could keep its interior warm, potentially creating a hidden subsurface ocean beneath leagues of ice. While life as we know it is nearly impossible, Planet 9 reminds us that the definition of a habitable zone is constantly expanding. To reach this world, a traditional spacecraft like New Horizons would take over 50 years, a journey spanning generations of scientists. We would need new forms of propulsion, perhaps giant solar sails pushed by powerful lasers based on the Moon or in orbit. Exploring Planet 9 would be like visiting a time capsule from the very earliest days of the solar system's chaotic formation. Its chemical makeup would tell us exactly what materials were present in the primordial cloud before the Earth was even a spark. This world is a missing chapter in our autobiography, a piece of the puzzle that explains why we are here and how we survived. Every month that passes without a sighting narrows the search grid, pushing astronomers to look deeper and think more creatively. Citizen scientists are even joining the hunt, scanning thousands of telescope images from their own homes through NASA-funded projects. It is a global effort to find a single point of light, proving that our curiosity as a species knows no distance or limit. Whether we find a planet of ice or a disk of dust, the journey into the outer dark has already changed us forever. We are no longer content with the map we were given. We are determined to draw the rest of the universe ourselves. If Planet 9 is ever confirmed, it will raise a profound existential question. Why did it take us so long to notice a giant? The history of astronomy is a series of humbling realizations that we are rarely at the center of anything important. We moved from being the center of the universe to the center of the solar system, then to a tiny speck in a massive galaxy. Finding a massive world in our own backyard that we simply missed would be the ultimate reminder of our current technological blindness. But it also highlights the incredible power of the human mind, to see the invisible through the lens of pure mathematics. Long before any telescope can confirm its existence, we have already seen Planet 9 through the way it moves its neighbors. This is the same way we discover black holes or dark matter. We watch the shadows to understand the light. If the math is right, this planet is currently near its aphelion, the furthest point in its orbit from our Sun. This means it is moving at its slowest speed, making it an even more difficult target to track against the background stars. It is a celestial game of hide and seek, where the hider has a head start of several billion years and a very dark room. Yet, the very fact that we are looking, that we care about a cold rock billions of miles away, is what makes us human. We are a species that cannot stand a blank space on a map. We are biologically driven to fill in the gaps. This drive led us out of the caves, across the oceans, and eventually to the Moon and the robotic exploration of Mars. Planet 9 is simply the next logical frontier, a lighthouse at the edge of the Sun's gravitational influence. Some scientists speculate that there could even be a Planet 10 or 11 waiting even further out in the Oort cloud. The more we look, the more we realize that the solar system isn't a simple family of 8, but a crowded, complex city. We are learning to stop thinking of space as a void and start seeing it as a landscape filled with hidden treasures. The search for Planet 9 is a victory for curiosity over complacency, proving that we haven't lost our sense of wonder. As the next generation of telescopes turns its gaze toward the outer dark, we stand on the precipice of a new era. The ghost is calling, and soon we might finally have the technology to reach out and touch it. But let's play the devil's advocate for a moment. What if the hunt for Planet 9 ends in a profound, echoing silence? Science is not a straight line toward the truth. It is a messy path filled with beautiful ideas that simply turned out to be wrong. History is littered with phantom planets like Vulcan, which was once thought to orbit between Mercury and the Sunday. Astronomers were so convinced of Vulcan's existence that they even claimed to have seen it during solar eclipses. It took Albert Einstein and the theory of general relativity to prove that Vulcan was nothing more than a mathematical misunderstanding. Could Planet 9 be our generation's Vulcan, a ghost created by our incomplete understanding of gravity's long-range behavior? If it doesn't exist, we must face an even more unsettling reality. Our current laws of physics might need a fundamental upgrade. Perhaps gravity doesn't work exactly the same way at the edge of the solar system as it does here on Earth. This leads us to the concept of MOND, modified Newtonian dynamics, which suggests gravity changes its strength at extremely low accelerations. In this version of reality, the strange clustering of rocks isn't caused by a planet, but by the very nature of space itself. However, the majority of the scientific community still bets on the particle over the law, a physical planet over a new physics. This tension between observation and theory is the engine that drives human progress and forces us to look closer. We are currently building eyes that are sensitive enough to see the heat of a single candle on the moon. If Planet 9 is out there, it has nowhere left to hide from the cold, calculating gaze of our new machines. The Vera Rubin Observatory will soon provide us with a census of the outer solar system, counting every rock and shadow. We are about to move from the era of maybe to the era of definitely, and the anticipation is electric. Think of the moment the first photo arrives, a grainy, cold, purple dot that changes the size of our home forever. It would be the most distant image ever taken of a world that belongs to our own sun's gravitational family. But until that pixel appears, we are left with the most powerful tool in the universe, our imagination. We imagine the mountains of methane ice, the dark oceans of liquid gas, and the silence of a billion-year-old winter. To find a world so far away, we have to look for the unseen using the unexpected. One of the most fascinating ways to find Planet 9 is by measuring the precise timing of distant pulsars. Pulsars are the universe's most accurate clocks, spinning neutron stars that emit a beam of radiation with perfect regularity. As Earth moves around the Sun, the gravity of a massive ninth planet would cause a tiny, rhythmic wobble in our position. This wobble would delay or advance the arrival of pulsar signals by a few nanoseconds, a signature we can actually detect. It's as if the entire solar system is a giant instrument, and Planet 9 is a heavy thumb pressing down on a string. Every nanosecond of delay is a breadcrumb, leading us deeper into the gravitational woods of the outer frontier. Beyond the math, we have to consider the neighborhood Planet 9 might have created for itself over billions of years. A planet of this size would likely have its own family of moons, perhaps captured from the surrounding Kuiper Belt. These moons would be frozen mirrors, reflecting the dim light of distant stars and the glow of the giant they orbit. If Planet 9 is a gas giant, it might even have a faint ring system made of dark, carbon-rich dust and ice. This would make it a dark reflection of Saturn, a shadow lord reigning over a kingdom of absolute zero. The discovery would also solve the mystery of why our solar system feels incomplete compared to others we've observed. Most star systems discovered by the Kepler mission have planets located in the gap between Earth and Neptune's size. Our system appears to be an outlier, missing the most common type of planet in the galaxy until now. Finding Planet 9 would mean we aren't the weird family on the block, we just hadn't met our biggest brother yet. This realization shifts our perspective from a lonely oasis to a typical member of the galactic community. Every new telescope we launch is a new sense we develop, allowing us to feel the texture of the universe. We are no longer limited by what our eyes can see, but by what our curiosity can imagine and build. The darkness is not a wall, it is a canvas, and the search for Planet 9 is our first brushstroke. Even if we never set foot on Planet 9, its mere presence would redefine the borders of our home. For centuries, we thought the solar system ended with the last planet we could see with our naked eyes, Saturn. Then, telescopes gave us Uranus and Neptune, and suddenly the neighborhood doubled in size. Planet 9 would push those borders so far out that the familiar planets would look like a tiny huddle around a campfire in a vast forest. At its furthest point, Planet 9 is so distant that light from the Sun takes nearly an entire week to reach it. Compare that to the 8 minutes it takes for sunlight to reach Earth, or the 4 hours it takes to reach Neptune. We are talking about a world that exists in a different relationship with time and light than anything we've ever known. But searching for it also teaches us about the vagabonds of the galaxy planets that have no sun at all. Astronomers estimate there are billions of rogue planets drifting in the interstellar void, cast out during the chaos of star birth. Planet 9 might be the only captured rogue we have, a bridge between our stable system and the wild, lonely galaxy beyond. To study it would be to study the orphans of the universe, the worlds that never had a home until our sun reached out. This search is a race against the dimming of our own technology, as these objects move into even more difficult regions of the sky. If we don't find it in the next decade, it may move into a part of its orbit where it remains hidden for another 1,000 years. The clock is ticking, and the stakes are nothing less than the completion of our map of the local universe. Every night, the Vera Rubin Observatory scans the sky. It is like a giant heart beating in the dark, searching for a pulse. We are looking for a shift in position, a tiny crawl of a pixel that says, "I am here," and "I am massive." When and if that discovery happens, it won't just be an astronomical event, it will be a cultural one. It will be the day we realize that even in our own backyard, there are still monsters and wonders waiting to be named. We will have to name this new world, perhaps following the tradition of Roman and Greek gods, or perhaps starting something new. But whatever we call it, Planet 9 will forever be the symbol of the deep dark, the final frontier of the sun's domain. Finding Planet 9 wouldn't just be the end of a search, it would be the beginning of a scientific revolution. Once we have a coordinate in the sky, every major telescope, including the James Webb, will turn its gold-plated mirrors toward it. We will analyze the light reflecting off its atmosphere to see if it holds water, methane, or even more complex organic molecules. We will look for moons, because the way they orbit Planet 9 will tell us its exact mass and density with surgical precision. This planet would become the ultimate laboratory for studying low-temperature chemistry, far beyond the reach of the inner sun. It might even challenge our theories of planetary migration, the idea that planets move around like billiard balls after they are born. If Planet 9 is sitting exactly where the math predicts, it means our models of the early solar system are surprisingly accurate. But if it's somewhere else, or if it's much bigger than expected, we may have to go back to the drawing board entirely. This is the beauty of science. The more we find, the more we realize how much we have left to learn. Some even wonder if the gravity of Planet 9 could be responsible for the periodic extinctions seen in Earth's fossil record. Could this distant giant be nudging comets out of the Oort cloud, sending them on a collision course with the inner planets every few million years? While this theory is controversial, it adds a layer of cosmic drama to our search. We are looking for our potential executioner. But for most astronomers, the hunt is driven by a much simpler emotion, the pure, unadulterated joy of discovery. There is something deeply poetic about a world that has been there for 4 billion years, waiting for us to become smart enough to see it. It is like a lost relative who has been watching us from across a frozen lake, silent and patient in the twilight. We are finally building the bridge to cross that lake, fueled by the same spirit that led our ancestors across the Bering Strait. The search for Planet 9 is a reminder that the map of the world is never truly finished. Every generation thinks they have seen it all, and every generation is proven wrong by a single, determined mind. As we wait for the data to trickle in from the edge of the world, we remain a species of dreamers and doers. The ghost in the dark is calling, and we are finally ready to answer. If Planet 9 is found, it will immediately become the most isolated and mysterious outpost of our solar system. Imagine a world where the sun is just another star, albeit the brightest one, providing no more warmth than a distant candle. On its surface, the daylight would be so dim that you could easily see the thousands of stars in the Milky Way even at noon. This environment would be an absolute playground for exotic forms of matter that cannot exist in the warmth of the inner planets. We might find oceans of liquid nitrogen or plains of solid neon, materials that behave like magic under such extreme cold. For scientists, Planet 9 is a bridge to the exoplanets, the worlds orbiting other stars that we can only see as tiny dots. Because it is so massive and so far out, it likely shares more in common with those distant worlds than it does with Earth or Mars. It is an exoplanet that stayed behind, a sample of the wider galaxy that we can study without traveling for thousands of years. But the search is also a reminder of the fragility of our own understanding of home. We once thought the solar system was a simple clockwork machine, but Planet 9 suggests it is a wild, unpredictable frontier. This giant has been there, tugging on the strings of our world, while we built empires, fought wars, and eventually learned to fly. It is a silent witness to the entire history of life on Earth, orbiting in the darkness for hundreds of millions of human lifetimes. Every time we discover a new layer of the universe, we find that reality is far more vast and complex than our myths ever imagined. The search for Planet 9 proves that the age of discovery is not over. It has only just moved into a deeper shade of blue. We are the generation that might finally close the book on the 8 planets and open a much larger, more exciting chapter. As the Vera Rubin telescope prepares its first light, the tension in the astronomical community is reaching a breaking point. Every pixel of data will be scrutinized, every anomaly investigated, until the ghost is finally brought into the light. Whether it is a world of ice, a primordial black hole, or something we haven't even named yet, the truth is out there. The universe is not under any obligation to make sense to us, but we are under a human obligation to try and understand it. So we keep looking, we keep calculating, and we keep dreaming of the giant in the dark. As we reach the final stages of our current search, we must prepare for the psychological impact of either result. If we find it, our world gets bigger, our history gets deeper, and our neighborhood gets a new, silent guardian. If we don't find it, we are left with a ghost that refuses to go away, a gravitational footprint with no feet. This missing mass problem isn't just a detail for astronomers, it's a fundamental gap in our understanding of gravity. It echoes the discovery of Neptune, where math told us exactly where to look before the first human eye ever saw it. We are in that same mathematical twilight now, standing between a prediction and a picture. But regardless of the outcome, the search for Planet 9 has already forced us to map the outer solar system in unprecedented detail. We have found thousands of smaller worlds, icy comets, and strange objects that we would have ignored otherwise. The search for the giant has revealed the beauty of the small, showing us that the void is actually a garden. This journey is a testament to the human condition. We are small, we are temporary, but we are incredibly persistent. We refuse to accept that there are parts of our own home that we are not allowed to see. We build machines that can see heat, we write equations that can weigh invisible objects, and we never stop asking, what's next? Planet 9 is more than a planet. It is a symbol of everything we don't know yet. It is the mystery that keeps us looking up at night, wondering what else is hiding in the long shadows of the sun. Perhaps, in a few hundred years, a 9th planet base will be a refueling stop for missions to the stars. Or perhaps it will remain a pristine, frozen monument to the birth of our solar system, untouched by human hands. The universe doesn't give up its secrets easily, but it does give them up eventually to those who keep looking. We are the ones who keep looking, driven by a spark of curiosity that started in a cave and now reaches for the abyss. The search for Planet 9 is our generation's great voyage, a mission to the edge of the world. And as we peer into the deep dark, we might just find that the universe is even more wonderful than we dared to imagine. So, as we close this chapter on the giant in the dark, we realize that the search itself was the goal. We have become better at looking, better at thinking, and better at appreciating the vast scale of our home. Whether Planet 9 is a world of blue ice, a tiny black hole, or a ghost of our equations, it has served its purpose. It has reminded us that the universe is still full of secrets, and that the age of discovery never truly ended. We are a curious species, living on a small blue rock looking out into an infinite ocean of stars. And as long as there is darkness, there will be humans building lights to see into it. The quest for the 9th world is a tribute to the explorers of the past and a promise to the explorers of the future. Whatever we find at the edge of the sun's reach, it will be exactly what we need. Another reason to keep exploring. Every telescope we build and every calculation we run brings us one step closer to the truth. Even if Planet 9 isn't there, the things we find while looking for it will redefine our science. We are no longer limited by what we can see, but by what we can imagine. The solar system is much larger, much stranger, and much more beautiful than our ancestors ever dreamed. From the fire of the sun to the freezing shadows of the Oort cloud, every inch is part of our story. We are the eyes of the universe, looking back at itself, trying to understand where we came from. And perhaps, somewhere out there in the deep indigo void, a cold world is waiting for its first visitor. Until then, we will keep searching, keep questioning, and keep dreaming. Because the greatest discovery isn't a planet, it's the fact that we never stop looking for one. Thank you for joining us on this journey to the deep dark. If you want to see more of the universe, don't forget to support our mission. Keep looking up.